We have the quadratic function here of f of x equals negative 2 times the quantity x minus 2, quantity squared, plus 2. It's a quadratic function because we have a squared term. The first thing we're going to figure out is our vertex, because this particular problem is what we call standard form. And standard form of a quadratic is in the form of f of x equals a times the quantity x minus h, quantity squared, plus k. And in this particular form, my vertex is going to be the coordinates h, k. So looking at this particular problem, I'm going to be subtracting 2, so that is my h. And my k is what's outside of the function, and that is also going to be 2. So my vertex then is going to be the point 2, 2. The next thing I'm going to do is find out whether it's a maximum or a minimum. Since my a is negative, that means that I have a sad parabola, and it's going to be opening down. So that means that the vertex is going to be at a maximum. To find my x and y intercepts, remember that the y-intercept is found by letting x equal to 0. So f of 0 is going to be negative 2 times the quantity 0 minus 2, quantity squared, plus 2. Negative 2 times negative 2 squared, plus 2. Remember to square the negative 2 first. So f of 0 becomes negative 2 times 4 plus 2, negative 8 plus 2, which equals negative 6. So then my y-intercept is going to have coordinates 0, negative 6. To find my x-intercepts, I'm going to set f of x equal to 0. So here's my equation. I'm going to have 0 equals negative 2 times x minus 2, quantity squared, plus 2. Now to solve for this one, I'm going to subtract 2 from both sides, and you end up with negative 2 equals negative 2 times x minus 2, quantity squared. Then I'm going to divide both sides by negative 2, and I end up with 1 equals x minus 2, quantity squared. I'm going to take the square root of both sides, and when I do that, I need to make sure I put in plus or minus 1. So I end up with plus or minus 1 equals x minus 2, which gives me, adding 2 to both sides, 2 plus or minus 1 equal to x. So my coordinates of my x-intercept then is going to be 3, 0 or 1, 0. 2 plus 1 is the 3, and 2 minus 1 is my 1. I'm going to start graphing, but before I graph, I'm going to have to figure out what my axis of symmetry is. And my axis of symmetry actually goes back up to my vertex, and the axis of symmetry is a vertical line through your vertex, and it's going to have the equation x equal whatever the x coordinate is of your vertex. So x equals 2 is my axis of symmetry. I'm going to use all the information I have now to go ahead and graph. My vertex is at 2, 2, so I'm going to graph that. That's the vertex, and remember that's going to be a maximum. And then I'm going to graph my y-intercept at 0, negative 6, and my x-intercepts are at 3, 0, and 1, 0. The axis of symmetry is an invisible vertical line that goes through my vertex. And the reason I use my axis of symmetry is because the parabola is going to be symmetrical about that axis. So any points that I have on the left side, I can also mirror image on the right side. So I have this point 0, negative 6 on the left. I can go ahead then and find the point 4, negative 6 on the right. And that gives me a pretty good idea then of what my parabola is going to look like. There it is. And then it's pretty easy for me to figure out my domain and my range. So my domain, if I go ahead and project this onto the x-axis, you can see that it's going to go from negative infinity to positive infinity. And my range always start in the negative direction, and then you're going to go to the positive. So in the negative direction, it just continues on down. So it's going to be negative infinity, and then it comes up, and in the y direction it stops at 2. And again, this can also be done by projecting your graph onto the y-axis.